What is up, everybody? I hope everybody's having a good night, morning, whenever you are watching this video. So this is 5.4, not 5.3. So we are moving away from all the different types of segments we've been talking about. So no centroid, no in-center, circumcenter, or orthocenter, no medians, no altitudes, no angle bisectors, nothing like that. We're just basically going to look at how triangles are structured and the inequalities that exist within them pertaining to both sides and angles. And so there's not a whole lot of new information today. It's going to strictly be based off of trying to figure out which angles or sides are the largest when we are given minimal amounts of information. All right. Now, before we actually start, let's review something really quickly. So remember when we were talking about isosceles triangles, and we knew that if two sides were the same, then the angles opposite them were also the same, right? And the converse of that was also true, in that if two angles were the same, then the sides opposite them were the same. Now that concept derives from there are limitations into how you can build a triangle, right? And so you can't just put any three lengths together to make a triangle. There's rules and there's restrictions. But that's for 5.5. Today we're just going to talk about how is it that we can determine which angles or sides are the longest if we know either all the sides or all the angles or some of the sides or some of the angles. And it kind of goes back to that isosceles triangle theorem, in that the angle measure is directly related to the side length across from it, and vice versa. The side length is directly related to the angle across from it. So when we look at this triangle, ABC, notice we have three different lengths, 6, 8, and 10. All three sides are different lengths. All three angles then are going to be different measures. So this is not an isosceles triangle. We don't have any two angles that are the same. But how are we able to tell which angle is the largest and which angle is the smallest? And the way that that's done is by looking at the sides and then traveling across the triangle to the angle that is opposite it. Because the theorem is the longest side of a triangle is always opposite the largest angle, and the smallest side is always opposite the smallest angle. So if I was to look at this triangle, our longest side is 10, the angle that is across from 10 is angle B. So that would make angle B our largest angle. Our next longest side is 8. Side 8 is across from angle A. So angle A would be our next largest. So that's saying angle B is greater than angle A. Then finally, our smallest side is 6, which is across from angle C. So that means our smallest angle is angle C. So what this statement right here is saying is angle B is greater than angle A, which is greater than angle C. Now I could write that from largest to smallest like I just did, or I could write it from smallest to largest. So angle C is less than angle A, which is less than angle B. That can be usually confusing because the angle symbols are looking the same direction as the less than symbols. So I usually like to write them like this because you're not going to confuse an angle symbol with a greater than symbol if you're reading it left to right. Okay? Now, if the largest side is opposite the largest angle, then it only makes sense that the converse of this would also be true, that the largest angle is opposite the longest side, and the smallest angle is opposite the smallest side. So looking at our diagram here, 110 degrees is our largest angle. The side opposite that side is side XZ. So that means side XZ is our longest side. The next largest angle is angle 50, which is opposite side XY. So our next longest side would be side XY. Followed up in the rear by our shortest side, which is opposite angle 20, which would be side YZ. So that would be listing them from largest to greatest. XZ is greater than XY, which is greater than YZ. And to be honest, guys, that's kind of like all the new information that is in 5.4, right? And so if you understand that concept, that brief little concept that we just talked about, you should be okay for the 5.4 homework. But let's do a couple more examples just so we get a feel of what homework's going to look like. So when I look at this problem, okay, notice I have some missing information. So we have to find some stuff before we can actually categorize the largest and smallest. So I have to find angle F. So in order to find angle F, I have two angle measures already. So all I have to do is do 180 minus 45 minus 56. That gets me 79 degrees. 79 degrees is my largest angle. So the side opposite it, the side that's not touching the vertex, right? So some people have a hard time determining what's opposite. It's the side that's not touching. So side GF is touching angle F, side HF touching angle F. So the side that we want is side GH. So GH is our largest side, followed by GF, which is opposite angle 56. And bringing up the rear is side FH, which is opposite the 45. Okay? So we just had to find that missing angle measure to complete that problem. For the next one, we're missing this side length right here, which we can find by using Pythagorean theorem. I'm going to call this side length Z for right now. Remember, leg squared plus leg squared equals hypotenuse squared. A squared plus B squared equals C squared. C is always my hypotenuse. So Z squared plus 64 equals 144. 144 minus 64 is 80. So Z squared equals 80. Go ahead and take the square root of that amount. That comes out to 8.9. So Z equals 8.9. So with that problem, our longest side is the hypotenuse, which is always going to be true for any right triangle. So now if we want to order our angles, angle W is our largest angle, followed by angle Y, which is opposite 8.9, and then finally angle X, which is opposite the 8. Okay. So now let's see, these first few problems I'm going to now do are from your homework. So I'm going to do maybe a couple of these on this page, a couple of these on this page. So there are, I believe, 16 or so problems on the homework. So you're going to have a couple after this that look just like these, 1 through 4, and then a couple that look just like 9 through 12. Notice the difference. This one's talking about sorting the angles based off side lengths, and these ones are sorting the sides based off angle measures. Okay, so looking at number 1, pretty straightforward, right? All I need to do is look at this. It says order the angles in each triangle from smallest to largest. So let's go smallest to largest. So my smallest side is 14, which means the side angle opposite is J. So angle J, I'm not going to put the angle symbol, so I don't want this to confuse. Angle J is my smallest angle. Actually, you know what? Let's do angle J and let's just do a comma. Followed by K, which is opposite the 16, and then followed by angle L, which is our largest. Now for number 3, my advice is just draw the triangle. Don't worry about drawing at the scale whatsoever. And then just throw in RQP, and then just label it. So QP is 15, RP is 25, and RQ is 13. Just so happened, worked out pretty well, right? So now, looking at this, once I have my triangle drawn out, it's very easy to see what's the largest side okay? And which angle is opposite it. So in this case, Q is opposite my 25 up, but we're going smallest to largest, that's right. So that means that P would be first because it's opposite my 13, followed by R, followed by Q, okay? So remember, guys, opposite means not touching. See how RP is touching R and a P, so Q would be opposite of RP. Let's just put that into practice now with our angles, listing them from shortest to longest one more time. So my shortest angle, or my smallest angle is 55. That's opposite GE. Next is 62, which is opposite GF, followed up by FE. One more time, go ahead and draw your triangle. Okay, VWX. Okay, and then V is 50, W is 48, X is 82. Based off that, smallest would be opposite angle W, so that'd be VX, followed by angle 50, which is XW, and then our longest side is VW, because it's opposite the 82-degree angle. Hopefully this is easy. Hopefully it's a nice little relief from the previous stuff we've been doing. Good luck. Let me know if you have questions. Please ask questions if you have them.